So let's do a problem involving the mean value theorem that's a little bit more abstract than the ones we've been doing. So um, here we have a function about which we know a couple of things. We know that f prime is less than or equal to 2 on the open interval 1, 4. We also know that the original function f of 1 is equal to 3. And we know that the function is continuous on the closed interval 1, 4 and differentiable on the open interval 1, 4. So the question we're being asked is the one I've underlined in red here, which is what is the maximum possible value of f of 4? Now, why is it that the mean value theorem would allow us to answer this? Well, I'll show you. According to the mean value theorem, taking this as a and this as b, we can say that f of 4 minus f of 1 over 4 minus 1 is equal to f prime of c for some c in for some c that exists in the interval 1, 4. If I rearrange this equation just a little bit, what I get is that f of 4 minus f of 1, I'm going to multiply both sides by this denominator, which is 4 minus 1, or 3. That gives me that must be equal to 3 times f prime of c for some value c. Now, what's the information that we're given? What we're given is this information that f prime of c has to be less than or equal to 2. So that means if this is less than or equal to 2, then that means that f of 4 minus f of 1 must be less than or equal to 3 times 2, right? Because if it's going to be equal to whatever f of c is, and we know that f of c can't be greater than 2, that means I can't be multiplying this 3 by anything larger than 2. So now rearranging the equation a little bit again, we can say that f of 4 is going to be less than or equal to f of 1 plus 3 times 2, which is 6. And that means that since we know that f of 1 we're given is 3, this problem has a little bit of a puzzle slash detective quality to it. This is going to be less than or equal to 3 plus 6, which is equal to 9. So if f of 4 has to be less than or equal to 9, that means that the maximum value of f of 4 is equal to 9. And by the way, when I talk about the max value, I'm not really talking about extreme values in the sense that we covered in the last section. I'm just saying, I'm answering the question. I'm just saying, if you want to know what the maximum possible value of f4 is under these conditions, then that has to be, then the answer to that is 9. Now, why is this true? Well, what we're given here is that f of 1 is equal to 3. And when we're told that the derivative can't be any greater than 2, what that means is that either the derivative is 0 or a negative number, in which case the function is heading flat or downwards, or if it is heading upward, in other words, if there's a positive slope, it can't be heading upward at any greater speed than 2 units up for every 1 unit across. So the max, it wouldn't be possible, let's say, for the function to just go from here and then just go zooming up at like a slope of 1,000. Why? Because we're told that the derivative can't be any greater than 2. So this isn't a possible scenario. The most it can go up is at a rate of 2, 2, and then another 2. If every time I move 1 unit to the right, I go 2 units up, that would take me 6 more units above where I am, which is exactly what this equation is showing. This is sort of the formal way that we get there through the mean value theorem. So, all right, so that's an example of a little bit more of an abstract problem with the mean value theorem.